All right, 5, 4, 5, 5, factoring polynomials. All right, factoring starts out with GCF, which stands for what, Justin?
Greatest common factor.
Greatest common factor. Okay, so what is a factor?
A number.
A number that does what?
It is more than one.
All right, number that's more than one. All right. Obviously, you guys need a little help with what is a factor. A factor is a number that goes into another number. For example, 2 is a factor of 4 because 2 goes into 4. 3 is not a factor of 4 because 3 does not go into 4. Okay? So that is a factor. What is the greatest common factor? Well, when things are in common, it's shared. Okay? And the greatest is going to be the largest. So this section is going to be about the largest number that goes into all of our polynomials or all of our pieces. Okay, so up here, there are several methods for factoring polynomials. Factoring out the GCF, factoring by grouping, factoring special products, looking for factors, factoring trinomials when A equals 1, and factoring trinomials when A does not equal 1. All right, this stuff back here, okay, this stuff is kind of where you just have to like see it. Up here, like 2 and 3 is more like there's patterns to it, okay? But we're starting out today with GCF. So up here we have 3 things, okay? We have the red piece, the green, and the blue. And a lot of you guys already started talking about like numbers that go in. And I'm going to start out with Hansi. And I know you guys overruled Hansi, okay? So Hansi said for you guys at home, Hansi said 3. And Hansi, you're not wrong. 3 does go into all of them, okay? And here's what happens, and this is what you do when you do it wrong, okay? And I'm not saying you did it wrong because there's a way to recover, okay? So Hansi said 3 goes into each of these. So here's what you do, Hansi. You take each of these and divide it by 3. So we're trying to figure out the GCF, okay? So you're saying 3 is part of my GCF. So if I do 6 divided by 3, I'm left with 2, right? I'll get to the x's in a second, right? If I do 30 divided by 3, I have 10. Okay? And then if I do 12 divided by 3, I get 4. And now it's at this moment, you look at it and you see, can anything else come out? So look at 2, 10, and 4, Hansi. Can I factor anything else out? What else could I factor out? I can't factor, because it's got to go into each one of them. So what number goes into 2, 10, and 4? 2. So at this point, you would say, okay, well, let me divide each of these by 2, okay? And again, I'll go back and deal with the x's. Okay, I'll put them in. So Hansi's like, okay, well, I was wrong. Okay, 2 could come out. So I had the 3 to begin with to get these numbers. Now I have a 2. So 2 goes into 2 1 time. 2 goes into 10 5 times. 2 goes into 4 2 times. Look at these numbers. Can I take anything out of those numbers? No. All right. So now we know the GCF wasn't 3, but it was actually 3 times 2, which is 6. And now you can see why Jay and Justin were right, right? But you weren't wrong because you're able to still get to this. You just didn't see, like that magic eye I was talking about, you just didn't see it at first. But once you get into the problem, now you can see like, oh, well, I can take out a little bit more than 3. I could take out a 2. So that's how we get to that. Now let's talk about the x's, okay? Because that's also part of it. Now, does everybody see how they share x's, right? How many x's do they share? Well, this comes down to what do those exponents mean? Well, those exponents mean I have 5 x's here in the first one, in the red one. I have 4 x's here, and then I have 3 x's in the blue one. So how many x's do they have in common? No, don't say 12. So how many can I take from 5, 4, and 3? 3. Okay. Leah, do you see that? Because if I have 5 here, then 4 here, and 3 here, I could take 3 from each one and still be okay. Because they all have 3. So I can take x cubed away. Okay? Now, long story short, the variables aren't your problem. It's the numbers. The reason why the variables aren't your problem is this. The greatest common factor for variables is always going to be, it's kind of the opposite what you think. It's always going to be the lowest exponent. So do you see how here was x cubed? So I took out x cubed because it was the lowest. All right. I couldn't take out x to the 5th because I can't take 5 away from 3. Does that make sense? Yeah. So Justin, to help you out, it's always going to be the smallest power of my variable. So that's why I took out x cubed. Now, what's left here? Well, if I do x to the 5th divided by x to the 3rd, remember we subtract those exponents, right? So it's x squared. Getting there. All right, with the 10, right? All right, let's do x to the 4th divided by x cubed. That's x, right? X to the 1st. I'm not writing to the 1st. X to the 3rd divided by x to the 3rd. They cancel, right? So I have no x's in my last part here. So I have here, but remember, all right, Hansi didn't see it right away. Maybe Hansi thought it was 3x cubed that came out, and this is what he would be left with, all right? So this is what's left after you're all done. After I'm done the whole problem, I was able to take out 6x cubed, okay? Do you see that? So the moral of the story is you want to see and try and figure out what is the largest number and the largest variable that goes into each one, okay? And to help you with that, it's always going to be the variable with the smallest exponent. And then you just have to worry about the numbers, okay? Now, I would try to teach you how to do it on your calculator, but your calculator only lets you put in 2 numbers. So I can't put in a 3rd number. And notice here, if I have 3 numbers, it's not going to really help me out. Because the greatest common factor of 30 and 12 might be different than 6 and 12. So it's not going to benefit you. All right. Let's talk about how this one equates to this one. Well, it's the same thing, okay? Just instead of commas, it's plus signs. So let's look at 6x to the 5th, 30x to the 4th, and 12x cubed. Hansi, what's the largest number that goes into each of those? 6. And Justin, what is the variable, the largest variable that I could take out from x to the 3rd? So to do this problem, okay, we are going to undistribute it, okay? Meaning this. I am going to pull out from each of these a 6x to the 3rd. Now, if you can see that we're just going to be changing the commas to plus signs, I think you can kind of see what my answer is going to be. But the difference between A and B is this one, I just kind of pull it out and see the GCF is 6x cubed. But here, I'm factoring. So I'm factoring out a 6x cubed. That's going to leave me with 6 divided by 6 is 1. X to the 5th divided by x third is x squared. 30 divided by 6 is 5, and it's positive, right? Because Positive 30 divided by positive 6 is positive 5. X to the fourth divided by x cubed is x. And 12 divided by 6 is 2. And x cubed divided by x cubed is 1. And I'm left with that. So this is my answer, which you can kind of see from up here, right? See it? You guys okay with that? So far, so good? All right. Now, with GCFs, we often just talk about positive. We don't talk about like the negative aspect of it, all right? Because remember, it's the greatest. So I wouldn't say like, oh, I can factor out a negative number from this. It really wouldn't be beneficial, especially in this format. So up here, let's go with Hannah. Hannah, can you hear me?
Yeah.
What is the largest number that goes into 24 and 32? Don't worry about the sign. Just think about what is the largest number that goes into 24 and 32?
8.
8. Now, Ed?
Yeah.
Ed, let's look at our variables. We have x cubed and x squared. What's the largest number of x's I could take out from each of them?
3 and
I have x cubed and x squared. So I have like 3 x's in the first part and 2 x's in the second part. How many x's could I pull out?
5.
I can't pull out 5 because I only have 3 and 2.
2.
2. I kind of think of it as, I don't know, it's going to be a bad analogy, but I'm going to go for it. Think about it like you have fruit baskets, right? Okay, you have like, in one fruit basket, you have like 3 apples, and in the other one, you have like 2 apples, right? So you could take 2 apples from both fruit baskets, right? You couldn't take, you couldn't take 3 from both because in one I only have 2. Okay, kind of think of it like that. That's a really poor analogy. That's the only thing I could think of. And sometimes that's what you get. All right. So I had said I can take out an x squared. Now what's left is this. 24 divided by 8 is 3. X cubed divided by x squared is x. And now I'm going to deal with the back guy. Negative 32 divided by 8 is negative 4. And x squared divided by x squared, well, that cancels. All right. So do you see how that's left? Do you see how I'm getting that? 24 divided by 8 is 3.
Oh.
X cubed divided by x squared is x. All right. No, I try to keep it in the same order because when I move to the polynomial, you're not going to want to start moving around pieces of the polynomial.
What's about that? What if it was negative 8 GCF? That'd be wrong.
All right, so Justin's asking, what about negative? Like, could I pull out negative 8? The answer is yeah, you could. But if you pulled out a negative 8, you'd be flipping the signs, right? So I'd be doing 24 divided by negative 8, and this would be negative 3. So I really wouldn't want to do that. There are occasions, and we will get to it, where I'm like, well, you're going to want to factor out a negative here because it's going to make your life easier. Okay, we'll talk about that when it comes. But when we're doing the GCF for this section, I only want you pulling out positive numbers, okay? And the cases where we pull out a negative number is we're going to get to a point where I'm going to factor what's left. So I'm going to have to factor out the GCF and then factor the remaining bit. Okay, that's what's coming. So in that case, like in this, okay, I'll talk about like, hey, I might want to consider factoring out that negative because what's left is going to make it a much easier polynomial to deal with. Okay, So up here, factor the polynomial 24x cubed minus 3x squared. Okay, I'm kind of thinking reverse distribution. I'm pulling something out from both of them. So here I would be pulling out 8x squared. And what's left would be 3x minus 4. Okay? And I can always check my answer. You should know if you got this right, Hansi. How do you know? Well, 8 times 3 is 24. X squared times x is x cubed. I'm good on the first part. 8 times negative 4 is negative 32. X squared times nothing is just x squared there. So I can always check my answer. Kaylin, are you okay with that? So at the end of these tests, you should know if you got it right or wrong. Okay? If I give you 10 questions in enough time, which you have, last year you couldn't do it, but this year you have a lot more time, you should be able to check your work and be like, oh, I got this one right, or oh, I got this one wrong. Okay? Got it? All right, now, Justin brought up a good question here for E, okay? Well, he was talking about pulling out a negative. For this section, okay, if I'm not going to harp on it. If you pull out a negative, you pull out a negative, and I'm going to probably count it right, okay? But I would like you to pull out positive numbers just because of just the nature of the section. But we'll do it both ways so you guys can see. Here, doing it the positive one, okay? What do they all have in common here? What can I take out of all the pieces? Jake?
3.
3. And that's it. Because they don't all share x, right? I have x's here, here, but I don't have anything with 18. So I can't pull out an x from all. But they're all numbers. So does the number go into 3, 12, and 18? Jake said, yeah. 3. So if I pull that 3 out, negative 3 divided by 3 is negative 1. X squared. 12 divided by 3 is 4. So 4x. Negative 18 divided by 3 is negative 6. Now, this is where I'm talking about with your stuff, Austin. Here, we're going to eventually have to factor that, if possible. In this case, it's not. But this, see how this negative 1 out in front? That, we don't like that. In math, we don't like it. We don't like that negative. So this would be a case that I would justify, well, Jake, would I pull out a 3? Yeah, I could, but then I have to deal with that negative there. Okay, and you'll see that when we start factoring this number in front and this number at the end are very important. So having them not be negative makes my life that much easier. So I could also take out a negative 3. Negative 3 divided by negative 3 is positive 1. I like that because it's positive. 12 divided by negative 3 would be negative 4. This really doesn't matter in the grand scheme of things.
Wait, so only the first number matters?
And then negative 18 divided by negative 3 would be positive 6. So when we move past this one section on greatest common factor, we're going to want to deal with things where that first number and that last number, okay?
The middle one.
No, the middle one does not matter that much. You want that first one to be positive, and that would be the case where I'd factor out that negative, okay? If you wrote either of these, the green or the red, I'm probably marking it right because, hey, it's good. Kind of where I'm going. All right. Any questions so far? Okay. To recap it, greatest common factor, I know there's more. Greatest common factor is the largest number that goes into each piece. Side note of that is with the variable, you're actually looking at the smallest variable exponent. Okay, that should help you. Okay. So like in C, the smallest variable is x squared. I already know I'm pulling out an x squared because I have x cubed, x squared, pulling it out. All right. You guys try. We got a, what is it, 3 right here? see if you can factor these three polynomials through the GCF. All right, you can go. Common knowledge, physical challenge, rock, paper, scissors, shoot.
And if
You can't go. What do you want? Choose a category. Common knowledge, physical challenge, physical challenge. Sure? You got slides on? No, it's simple. Physical challenge is this. Head, shoulders, knees, toes, knees and toes. Got it? You have to do it as quickly as possible. If you can beat me, my time, you'll go first, so you set the standard. If you can beat my time, you get to go. But if you don't get to go. Let me get my time. You want to warm up, and I want you to pull a hammy.
wait, so it's head, shoulders, knees, toes.
Yep. You ready? Set, go. You look like an absolute fool doing that. You can go. I force that. I can't believe you would actually do that. No, I don't ever do it. I just can't
So
believe
then
it.
why did you make him?
Because it's funny. It is really funny. Put a smile on Hansi's face. It is funny. I did not think this class was going that way. Isaac, you okay back there? I approved your extension. Okay. I think I gave you till like Monday. You all right with it? You good with that? Al? What number is going to 28? Right there. Well, they're both even. So you know 2 goes in there. Okay? So my advice would be divide them both by 2 and see what's left. You got it, Jack? Because look, they don't have anything left. 3 and 7. Can't go into that. This one doesn't have a Y. No one does. This one has X's. This one doesn't. You're good.
So would this be 6x squared plus 4xy squared?
Jake, I'm going to be honest, I have no idea what to do.
It's a 6x squared plus 4xy squared.
What goes into 12 and 28? You said 2, right?
Yeah.
It's 28 divided by 2. 14.
Yeah.
So it would be 6.
Yeah.
6 and 14. They're both still even, right?
And it's xy squared.
Well, Jake, you gotta get the variables out, and you have to get the numbers. 6 and 14. They're still both even.
Oh, wait, you can make them smaller.
So I can make them smaller. Remember, it's the greatest.
So 6, you can. Oh.
So it's 12. So remember, you do 12 and 0. So you're off to a good start. So if you look at 6 and 14,
I got 3x squared plus 7y squared.
Yeah, but the GCF, so write that number outside. So that's good, sir. All right, let's look at the first one together. I'll let you guys work again. Okay. First thing I'm going to break it down to is the numbers, 12 and 28. A lot of you guys saw 2 first, so I'll start out with 2. Okay. So I'm thinking 12 divided by 2 is 6. 28 divided by 2 is 14. All right, and some of you guys may be able to hear it when I'm walking around, but this is what's going through my head. I know this isn't done because 6 and 14 are still both even numbers. So I know at least 2 goes into them. So if I know 2 goes into them, I'm going to take another 2 out. So I have the 2 out here. I'm pulling another 2 out. That's going to be 4. 6 divided by 2 would be 3. 14 divided by another 2 would be 7. Okay, so that's where I'm at, just with the numbers. Now with the variables, I noticed this. I noticed the first one's got x squared and the second one's got xy squared. I'm not worried about the y because they both don't have y's. They both have 1x. This one's got 2. The second one has 1, x to the first. So I will pull out an x. Okay. All right, so here's what would be left up here. I'm just going to fill this in. Don't worry about it. Down here. Hopefully you see this. Hopefully you're getting there. 12 divided by 4 is 3. X squared divided by x is x. See that? 28 divided by 4 is 7. Xy squared divided by x. Well, I'm not really worried about the y part, right? Because x and y, they don't have anything to do with each other. So x divided by x is 0. They cancel. And I'm just left with y squared. I'm going to check my answer. I'm going to look. Notice in this back part, this one has an x. That one has a y. I know I got my variables out. 3 and 7. 3 and 7. There are no numbers that go into 3 and 7. How do I know that? Well, they're both prime numbers. So those divisibility rules back in like 3rd grade, they're going to help you. I love them. Well, I'll give you one piece of advice. If you're left with even numbers, 2 can go into it. All right? Try 2 and 3, keep going.
But how do you get rid of the x?
What's x divided by x?
Oh.
They cancel, right? If I have x over x, they cancel.
Oh. So wait, what x did you divide it?
When I factor out, Jake,
Oh.
when I factor out, I'm dividing.
So you're dividing everything by x.
Yes. So in my brain, this is what I'm thinking of. 28xy squared over 4x. 28 over 4 is 7. X over x, they cancel.
Yeah.
Y squared, still there.
So you did the top divided by bottom.
Yeah.
Oh, okay.
Did you get it? Did you get the second one? Justin's not doing much of anything. It's amazing that you don't have a notebook either. Unreal. Unreal. Chris Dolan.
Yeah.
Chris.
Yeah.
What number goes into 54 and 36?
18.
18. Okay. To be honest, when I looked at them, I didn't see 18 right away. I saw 9. I didn't see it. All right. I have, good for you. All right. Remember, if you don't see it right away, look back. Check your work. So Chris saw 18. Okay. So I'm pulling an 18 out. Now, it's only 18 because the first number has an x squared. The second number has nothing. No variable. 54 divided by 18 is 3, so 3x squared. 36 divided by 18 is 2. So it's minus 2. Chris, is that what you got?
Yes.
Perfect. Now, the last one, let me go over. Okay. I got 3 parts. 1, 2, 3. I'm trying to pull something out that's in common with each of them. First thing I'm going to deal with, which is probably the easiest, I'm looking at the variables. X's and Y's, X's and Y's, and X's in the last one. That's telling me that Y's I'm not going to be able to factor out because they're not in common with each of them. The only thing that's in common variable-wise is X. And I'm going to look for the smallest exponent of X, 4, 3, 2. The factor out an X squared. Okay? Now let me look at the numbers. 14, 21, 9. Well, let's see. 14 is composed of 2 and 7, right? Well, 7 goes into 21, but 7 doesn't go into 9. Well, 2 doesn't go into 21, so no number can be pulled out. So the only thing I can pull out is an X squared. So I'm going to be left with 14 X squared Y cubed plus 21 X Y squared plus 9.
X squared.
No, I pulled that out.
Oh.
And that's it. You guys okay with that? All right. That's where I'm stopping today. Not because I